Welcome. Today we are going to talk a little bit about Venn or Euler diagrams. Depending on your point of view, how technical you want to be, you will hear these diagrams referred to in both cases, and I'll explain the difference between them later on. So what is a Venn or an Euler diagram? So let's say we've got different categories that have overlap and differences. So for example, let's have a set of people that are really good at English. So really good at English. So we use curly brackets in maths for groups. I wouldn't worry about that too much. But let's say we've got Louis is good at English, Alex is good at English, Nick is good at English, and we'll go Dav is good at English. Now, simultaneously, we've also got a group of teachers at MySpace that are quite good at maths. So, for example, we've got Neil. It turns out Nick is also quite good at maths. And then Dav is okay, I guess. Who else is probably good at maths? We've got LaJoy and we've got Brooke. All right, not an exhaustive list, but just off the top of my head. So, what we would quite like is to figure out which teachers, or which people, sorry, not teachers, might belong in one group or the other, and so on and so forth. So what we're going to do is we're going to draw a shape. I'm going to go with bubbles because I am not that imaginative, but there's nothing stopping us. So the red bubble here, we're going to put in here everyone that is good at maths. And just to help ourselves out here, let's do a big square. All right, most mathematicians will just use bubbles, but we can use squares as well. That's not a problem. And actually, let's make this big enough because my handwriting is shocking. All right. So in this shape here, we're going to put all the people that are good at English. Now, what we want to do is always start with, we're going to look at the ones that are in both groups. So Nick is actually quite good at English, and so is Dab. So, and if we have a look, they are the people that are in both categories. So if I put these names in here, Nick and Dav are both in the really good at English group, and they're also in the really good at English group and the really good at maths group. Now, Louis and Alex are both really good at English. They need to go in this box here, but they are not also really good at maths. So they need to be in the English group, but not in the maths group. And same for our other ones here. Okay. Now, what you'll probably see as we go through this is that we tend not to write whole words in math. So we would, instead of writing whole, we would go, oh, that is group M, and say that is group E. And the other thing we can do is we can start writing down, how many people there are in each. So let's say there are Neil, LaJoy, and Brooke. There are 3 people that are good at maths, but not particularly good at English. There are 2 people that are good at maths and good at English, and there are 2 people here. And we could even, if we really wanted to, start putting people on the outside. I realize now this is going to be super harsh, but there we go. So for example, Joe and Guy, just pulling names out of a hat here. Who else do we have? Oh, let's go for Manny. All right. Okay, and these would be individuals that aren't classified as good at maths or good at English, which is not the case at all, but there are 3 people on the outside there. This already here is basically a Venn diagram or an Euler diagram. All right, what we sometimes do as well is to indicate that this is everything that can ever be, we will box the entire thing up. Okay, that is the key. That is our key idea here of this is how we're going to represent different groups of things, of individuals, and what categories they belong in. That is all we are doing with a Venn diagram. All right. Now we've got some funky notation to help us out here. So here, for example, I've got a bunch of numbers. Some numbers are in group A, some numbers are in group B. All right, some numbers in one, some numbers in the other. Some in both. And we've got notation for that. So what we'll notice is, let's look at this one here. This is the intersection, A and this upside down UB. That represents the numbers that are in A and B. So in our case here, the numbers in A and B is just the number 2 is in both of these. So here we've got individual numbers. All right. Now you can think of this as A And this can be, you can think of it as and, right, a big upside down N. The complement, now let's have a look here. A dashed or AC, we're probably going to use the A dash symbol, is the things not in A. So what numbers in here are not in A? Well, 1 is not in A, all right, 9 is not in A, 4, 6, 8, 10 are not in A. Those are all the numbers that are not in A. And now we've also got this idea of U, which is the union. In maths and in science, we call that OR. Now, OR does include both, right? If you like chocolate cake or raspberry cake and you have a chocolate raspberry cake, you will love that cake, right? So OR does include both. So A or B here is anything that's in A or in B. So it's the big red peanut here. So the numbers in A or B will be 3 in no particular order: 3, 5, 7, 2, 4, 10, 6, 8. Okay. So we've got this notation which we may or may not have to use, but it's useful to have under our belt. So again, here in this case, we are listing out all the different items that are in both groups. We could also just write down how many there are. So there is only one number in the intersection. There are 1, 2, 3, 4. There are 4 numbers only in B. There are 3 numbers only in A. And there are 2 numbers on the outside. So we can either list out the different elements, or we can write in the different sections how many of each there are. So just as a little practice, what items here are in the set not A? The set not A. So all the numbers that are not in A. So 8 is not in A, 7 is not in A, 2 is not in A, and 5 is not in A. Being able to identify these different areas in the diagram is going to be key for us as we use Venn or Euler diagrams for UCAT questions. A or B, anything in A or in B, the union. So 1, 9, 3, 11, those are all in A. 1, 9, 3, 11. 6 and 10 are definitely in A or B because they're in both. 7 is in A or in B. All right, not A and B. So we need to simultaneously be not in A, but also in B. Well, that is going to be the number 7. The number 7 is not in A and in B. Now, just like with bid maths, A and B, but not. So we need to not be in A and B. So all the elements that aren't in the intersection. So the intersection is here. These are the numbers that are in the intersection. Now we want all the numbers that aren't in there. Well, 8, 1, 9, 3, 11, 7, 2, 5. Now let's set up a Venn diagram for ourselves from some information that we've been given. So we got a book club. People prefer fiction books or non-fiction books. Let's set up a Venn diagram. You won't always have to put a big box around it. Now we can go for one circle. We'll call that fiction. And you know what? Why not? You can use any shape you want. All right. Oh, 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 isn't that exciting? Look at this. There we go. That's wonky as all hell, but there we go. So we've got the people that enjoy fiction books, and we've got the people that enjoy non-fiction books. And I'll tell you what, let's create a little bit more of an overlap. The shapes themselves do not matter. Their job is to make it so you can clearly see which items are in which group. Now we know 28 people prefer fiction books, but that is 28 people overall. Okay, so that includes the people that like fiction and don't like non-fiction, and the people that like both. So we're going to put a pin in that. 18 members prefer non-fiction books. And again, that does include the ones in the middle and the ones not in the middle. So we're going to put a pin in that. However, 8 members enjoy reading both fiction and non-fiction. So I know there are 8 people that enjoy fiction and non-fiction. Now I can go back. 28 members prefer fiction books. So overall, there needs to be 28 people in the fiction bubble. Well, that means I need 20 over here, because then total is 28. And same, I need 18 people total in my non-fiction pentagon. So that needs to be a 10. And now I can start looking at, well, how many people don't like fiction or non-fiction? Well, how many people have I represented so far? 20, 28, 38. There are 45 members. That means there are 7 members that don't like either. How many members do not prefer reading either fiction or non-fiction? 7. Now, a very interesting thing to look at here, though, is if we look at the number of fiction books, 28, and we add on the people that like non-fiction books, that will give me 46. All right, which is more than the total number of people in the group anyway. So why is that? Well, it's because when I do 28, so if I look at the totals of these two bubbles, right, I can't just do 28 plus 18. Why? Because that 8 is included in the 18 and in the 28. So if I write that over here, the number of fiction book people is 20 plus 8. And the number of non-fiction people, well, is 10 plus 8. And the issue occurs here that I've counted these 8 people twice. All right, and you'll see what's going to happen on our next slide for that one. Okay, but bear that in mind as we go into our next slide. So we do need to be very, very careful. Just adding the number of fiction and non-fiction books here gives me a number that's bigger than the number of book club members. That is because of these middle people that we have to be really careful about. So let's go to a book club instead. I'm going to make my life a little bit nicer because this is how I operate in my day-to-day. And yes, I do Venn diagrams in my day-to-day. But tell you what, let's make this one blue. So we're going to look at the number of people that like action films and the number of people that like romantic comedies. Now again, if we have a look, 25 members prefer action films, 12 members enjoy romantic comedies, but 32 of them enjoy reading either of them. So there are 32 people, if you remember, back to this slide here, that either or is the big red peanut, is everything inside a bubble. But the problem is, again, here that we might see is if I do my action films 25 plus my romantic comedies 12, that gives me 37. But I've told you there are only 32 members. That is bigger than the 32. Now, why is that? Well, because there is a certain amount of them that are in here in the middle. All right, there are a certain amount of them that are in here in the middle. And when I do 25, that includes whatever's in this group plus that middle bit. And when I do the 12, that includes the middle bit as well. So the middle bit has been counted twice, which is why this number is too big, because it's got an extra lot of that middle bit. So how much too big is it? Well, I get 25 plus 12 is 37. I should get 32. So I'm 5 too big. If I'm 5 too big, that is going to tell me that the middle, that is because the middle bit has been counted twice. So that's telling me that the middle has to be 5. That overcount here, which makes this number too big, is because of this middle bit being counted twice. So how much am I over by? By 5. And we're sorted. Right, now we can fill it in. 25 members enjoy action, so that's 20 only enjoy action. 12 members prefer rom-coms. Well, if 5 of them also like action films, 7 are outside here. And that means 32 members prefer dramas, documentaries, whatever it is. So that the total comes in at 45. So how many members do not enjoy either of them? 13. Now we can do it with more than 2 groups, and this is going to be clutch for us later on. And here we've got 3 groups. So what we're going to do is I'm going to be that guy, and I'm just going to do it in a bunch of multiple shapes. There we go. Rather than colors. I prefer the shapes to the colors. So some people in this book club prefer mystery novels, some enjoy sci-fi, and some enjoy romance. Now we're going to need to fill this in. So the first thing we want to do is always start and try and fill in from the middle. So do we know that? We know 45 enjoy mystery novels, but that's everything. The people that like mystery, the ones that like mystery and sci-fi, mystery and romance, all 3, etc. So do we know anything about all 3? 3 members enjoy all 3. Well, we know 3. Bosh, done. 5 members enjoy sci-fi and romance. So these guys here enjoy sci-fi and romance. There needs to be 5 of them in total. Well, I already know 3 of them enjoy all 3. So there's going to be 2 right there. Bosh. 10 members enjoy mystery and romance. Oh, have I put this 2 in the wrong one? It was romance and sci-fi. So that's up there. 10 enjoy romance and mystery, so that needs to be a 7. So that now overall here we get 10. 20 members enjoy mystery and sci-fi. This little 2 has caused a lot of problems. It should go there. Right, 20 members enjoy mystery and sci-fi. So that needs to be a 17. And now we're up and running. 15 members enjoy romance. So at the moment, I've got 12 people in my romance triangle. So I'm going to want 3 people do not only enjoy romance novels. 30 members enjoy sci-fi novels. 17 plus 3 is 20, plus 2 is 22. So there needs to be 8 out there. And then 45 members enjoy mysteries. So 17 plus 3 is 20, 27. Off the top of my head, that should be 18 members out there. And now we can see how many people we've included altogether. 18 plus 17 is 35, plus 5 is 40, plus 10 is 50, 58. Have we got everything we needed here? 18, 35, 40, 50, 58. So that means there will be 62 members that don't like any of those. So how many members enjoy mystery novels only? 18. How many do not enjoy science fiction novels? So how many are not in the science fiction box? 18 plus 7 plus 3 is 28, plus 60 is 90. Do not enjoy any of them, 62. Now, finally, what is the difference between an Euler and a Venn diagram? So here I've got 3 groups, right? 5 members are only in A, 5 in an overlap between A and B, so on, so forth. Now we'll notice there's no overlap between A and C. This is for your own edification. This is an Euler diagram. But it often gets called Venn diagram because in maths we just call everything a Venn diagram. Now, the difference being is that if I was to draw the Venn diagram, a Venn diagram includes all possible options. So this would be a Venn diagram. Because the point is, even though there are no elements that are in A and C, on a Venn diagram we include that. All it means is there are no elements in A and in C. There would be none there. So there are 5 elements in A and B. There are 5 elements in A. There are 13 elements crossover between B and C. 4 elements here, 10 elements there, 7 elements there. So this would be the equivalent Venn diagram. Voila. I hope that clarifies for you a little bit Venn and Euler diagrams.